Well, hello, everyone. Thanks for joining us here at the Boston Globe Future of Medicine Conference. I'm really fortunate to have my friend Bob Langer here to share some of his wisdom about medicine and about chocolate, which are both very important things in our lives. I'm just going to kick things off, introduce myself and introduce Bob, and then we'll dive right in. My name is Jon Chesto. I'm business reporter for the Boston Globe, and among many hats I wear there, I write Bold Types, which is a column that looks at the various people in the business community here in Boston. There's a never-ending font of news in that column. I can't keep up with it. I'm always weeks behind. I did feature Bob, and I'll explain why in a second. But I wanted to just give a little bit of a bio for Bob. I have to look it up. I have to cheat because it's so long that I cannot memorize it. So bear with me a second here as I try to find it on my phone. It's so long. So I will say, well, he is one of 9 institute professors at MIT, co-founder of Moderna, which is probably the most well-known of the companies he's co-founded. But I think it's safe to say you've co-founded dozens of companies. Is that a modest number? He's a prolific inventor. His research and patents has fueled the launch of countless biotech ventures, shaping the future of medicine. He has over 220 major awards. I didn't count them, but it goes. You could scroll down for a while. 45 honorary doctorates. He's built a career at the intersection of science and entrepreneurship. And we're going to talk a little bit about, his career, what he's up to now, and the state of affairs in the biotech industry that he spends so much time in. First of all, let's dive in. Talk about, Bob's got all these honorary doctorates. I mentioned more than 40. I barely got through high school chemistry and science, so we don't really share that in common. But we do both share a love of Falmouth and a love of sweet treats such as chocolate. And I profiled Bob last year because they made a chocolate in his honor at Ben and Bill's in Falmouth, which is that big candy shop on the main street of Falmouth. And before we get into the hard-hitting questions, I want to hear about how to maybe tell the audience how that came about and what was the chocolate like? What did you think of the chocolate?
Yeah.
This is the important stuff, folks.
Right, sure. Well, when I grew up in Albany, New York, and when I was a little boy, there was my grandmother used to take me to a place called Siddick's, and they had these dark chocolate creams. I guess they had milk chocolate creams too, but I don't like milk chocolate as much. So I love that, and they had dark chocolate maples, dark chocolate, coconuts, all this. So it turns out when we got a place in North Falmouth, well, maybe a little over 30 years ago. And this place was just like Stiddick's, that they had an incredible candy selection. So we'd start going there a lot, and I'd grab these, get these candies. And during COVID, we were actually stayed in there for 7 months in Falmouth. So, we'd get quite a lot of chocolate. And so they knew me. So my son, I guess, talked to the woman who owns it about could they, for a birthday present, make this special chocolate, which is a chocolate covered maple. It's got chocolate covered maple cream, but then with more maple on it. So anyhow, she did that and put it in my name. So
how did it turn out?
Oh, it's great. Well, I gave you some before, so you have to do a taste test.
So after your time growing up in Albany, you obviously entered the medical research field. Tell me a little bit about what brought you to this field. I got to think you started at a young age.
Yeah, well, so again, I would love to tell you that I had this really well thought out career, but I didn't. I ended up majoring in well, first of all, I ended up becoming an engineer because when I was in high school, my dad and guidance counselor said if you were good in math and science, that's what you should do. And I was pretty good in math and science, and I was terrible in everything else. So became an engineer. And then when I went as an undergraduate at Cornell, the one set of classes I was good at and I enjoyed were chemistry. So I became a chemical engineer. And I went to undergrad, and then I went to graduate school, actually at MIT. And when I got done, pretty much all my friends, this was 1974, they went to work for oil companies. So I thought I'll do that too. And then I'd go in these interviews, and they talk about how you could just increase the yield of some of these chemicals by incredibly tiny percentages, and how wonderful that would be, be worth billions of dollars. And I just remember flying back to Boston after each of those interviews thinking I just didn't want to spend my life doing it. So it made me think, well, what did I want to do? So I thought about when I was actually a graduate student, I helped with some other people get a school started as an alternative high school for working class kids in Cambridge called the Group School. And what I really worked on was chemistry, science and math, and developing new chemistry curricula. And then one day I saw an ad to do something like that as an assistant professor at City College of New York. So I wrote them a letter applying for a job. That they didn't write me back, but I liked the idea. So I found all the ads I could to do something like that, maybe about 40, and I tried to. Anyhow, I wrote them, and I don't think any wrote me back. So then I started thinking, what other way could I use my chemical engineering background to help people? And I did. I thought about medicine. I wrote to a lot of hospitals and medical schools who also didn't write me back. But finally, one day I walked into the lab where I was at MIT, and one of the older scientists said to me, Bob, there's this surgeon named Judah Folkman at Boston Children's Hospital. And he said, sometimes he hires unusual people. So I went to Children's Hospital, and I worked there, and that really changed my life. I was the only engineer in the entire place, and Dr. Folkman was a visionary person, and so that's kind of how I got into the medical area back in 1974.
And if you look at a lot of this, what you specialize in, it's in the drug delivery business or drug delivery research, how to get drugs more effectively and to work more effectively, to have people accept them more effectively. How did that come about? It's not something I really even thought of as a subsector of medicine.
Yeah.
Did you think about it? Did you fall into it accidentally, or talk a little more
I
about
think
that?
probably accidentally is right. So Dr. Folkman's idea was that if you could stop blood vessels, that might be a whole new way to think about treating cancer and possibly some other diseases. It turned out it was a most people thought he was wrong. At any rate, he hired me to prove he was right and to actually isolate what would be the first substances that could stop blood vessels. But there was no way to study blood vessels really at that time. Almost everywhere you go, there's background blood vessels, and we've figured out some ways to maybe visualize them, but it would take a long time. So our idea is we'd put a tumor in certain sites, and and then we wanted to have a tiny particle, like a nanoparticle or a microparticle, that could deliver different molecules to the tumor, to the where the blood vessels might go. And in particular, we wanted our thought was that the molecules that would stop blood vessels were large molecules. For reference, proteins are large molecules, DNA and RNA are large molecules. So that had never been done. In fact, 1974, when we did this, there was really only one company in the world, a company in California called Alza, that was working on what I call advanced drug delivery systems. They would later, none of these were out yet, come out with these transdermal patches that people wear sometimes. But anyhow, Dr. Folkman was on their board, and he asked them, and they had very famous chemists, Nobel Prize winners on their board. He asked them, could they help us? And they all said, well, this is impossible. It could never work. But if we were going to solve the blood vessel problem, we had to solve that problem. So I spent several years in the laboratory experimenting with different approaches. I actually found over 200 different ways to get it to not work. But eventually I did. I figured out a way to deliver these large molecules, and that ultimately over the years, we and others have advanced that. That was a paper we wrote in the journal Nature in 1976. It was the first time that had been done, and it did enable us to ultimately find blood vessel inhibitors and lots of others after us. And those are now widely used for treating cancer, for treating diseases of blindness in the back of your eye. And of course, the drug delivery systems they're used in lots of things today.
Let's talk, maybe I mean, out of all the companies you founded, is there one that you're particularly proud of? One you have a favorite, or is that really hard to say? You
Yeah,
know,
I think it's always hard to say. It's like I have 3 children, so it's kind of almost like if somebody asked me who's my favorite child, I would have a hard time answering it for lots of reasons. And it really has to come down to criteria that you'd use for, I'd say some. I mean, Moderna, I feel, has changed the world. I'm very proud of that. Alnylam, I was in the founding scientific advisory board. They've created a lot of new medicines. Momenta was another one that we, that created. We just got approvals for autoimmune diseases like well, now Johnson and Johnson owns it, but for like myasthenia gravis. But all of them, some are early, and I believe have enormous potential, and so I mean I'm kind of proud of all of them, just like I am of my kids.
talk a little bit about Moderna. I mean, everybody here knows the company. Obviously, like you said, it's a world-changing medicine that they created at the time of the pandemic. What role did you play in sort of getting them off the ground?
Yeah. Well, scientifically, it would go back to what I mentioned earlier, because we created the first nanoparticles or microparticles, tiny systems that could deliver RNA. And no, people thought that was impossible. And we had shown you could do it, and we, over the years, advanced that in many ways. But what happened in the case of messenger RNA therapeutics, people had worked on messenger RNA as a possible therapy. It was done in animals. And then there were some people at Penn, Caitlin Carrico and Drew Weissman, and they figured out a way to modify RNA so that it wouldn't cause some problems in the body. Derek Rossi, who was a professor at Harvard, actually advanced that even further, showing how you could change the nature of certain cells by that in a positive way. And he came to see me, and he had tried to get funding to start a company. Actually, they did too, and nobody would give them money. And I thought that that probably we could solve some of the problems like delivery, because if you just gave RNA by itself, it would just get destroyed. So since we had done delivery systems, I had hopes that maybe we could do something like that. We got Ken Chen, who was a cardiologist, involved, and Nubar Fayan, who was actually, I was on his thesis committee. He's been an incredibly successful investor and just a visionary guy. And so the four of us thought, well, why don't we try to create a company that can do this? And when you try to start a company, you sort of are involved in doing everything. We got together once a week for, like 6 months, trying to figure out strategies and patents and things like that. Then we were able to. Newbark said to me one day, "Well, there's this guy Stefan Bonsell who he knew, and actually I had met him too because I did some consulting for the company he was at." He said, "Geez, he'd be an unbelievable CEO if he would come," and he did. And then we got other great people like Stephen Hogue and Melissa Moore, and it went from there.
What kind of exciting projects are you working on now, the projects that your lab's working on now that we should be watching?
Yeah, well, so we still do a lot in drug delivery and kind of tiny capsules and things like that. In fact, probably the biggest set of projects we do in that is with the Gates Foundation to try to take some of the things like what we've done has led to a lot of new therapies for all kinds of diseases. I mean, it's not just us; it's lots of companies and lots of scientists, but for what I'll call the developed world. But Bill Gates, came to see me about 12, 13 years ago and said, well, could we do some of that for the developing world? And of course, there's different constraints when you do that. You need it to probably be cheaper. You need it to be, stable, and you need it to. And one of the biggest issues is people don't. They have different customs, and they don't take drugs. They won't take drugs or vaccines maybe more than once, just because they don't come back. So examples of what we've done, like say you had a vaccine, one of the things we're doing, and it could be mRNA, but it could be anything. We started way before COVID. Is could you give a vaccine where you just give one injection and it'll last for the rest of your life? How could that be? Well, you could create capsules that break at different times to release the vaccine, and you make a cocktail of those. So Anna Jakelenic and others in our lab created systems like that. It's by a new kind of printing system. And another example is in nutrition. If you go And I mean, just to pick an example, and people may not be aware of this, like if you go to Nigeria, over something like 20,000 people, mostly children, die a year because they don't get vitamin A. And you'd say, well, couldn't you ship them vitamin A? But they won't they won't matter. They won't, it's not part of their customs. What is part of it is drinking, it's having bouillon. But so Bill said, well, could you ever come up, and his colleagues, could you ever come up with a way where you could boil something for 2 hours, because that's, and nothing happens to it. And then when you eat it, it all comes out. I mean, it might sound impossible, but anyhow, we came up with a way to do that, and that hopefully will be, you know, it's already been approved by Codex. That's kind of like the world FDA for nutrition, and and I hope that that'll be introduced next year in places like Nigeria and other places. Another example are pills you could swallow that might last for a week or a month to improve compliance. So there are a whole range of things like that. So that's one set of things that we work on in sort of drug delivery. And there's other things. I mean, better nanoparticles, artificial intelligence, and some of those things. And then the other big area that we started along with Jay Vacanti, who is a surgeon at Mass General and before that Children's, who's a good friend of mine, is this whole idea that you could make tissues and organs from scratch. And that you know, we probably started again back when I met him in Dr. Folkman's lab in the 70s, and that's led to new skin for burn victims. It's led to actually another one of my former postdocs, Laura Nicholson. She started a company to make new blood vessels, and that's already used to treat soldiers in the Ukraine, and got FDA approved. But we're working on lots of other tissues and organs too. But then the other side of that is you could actually maybe make tissues and organs on a chip. So one of the things that Alice Stanton, who was one of my postdocs, and along with Liu Tsai at MIT, so we actually are creating almost like what I call personalized brains on a chip, where she's been able to take you know, like I could take your cells, convert them into a certain cell type, and convert each of those to the 6 different brain cell types. And
What
then
would that be used for?
well, drug discovery. I mean,
Yeah.
because see, right now, if you try it, like, let's just pick Alzheimer's, which Li Wei is an expert on, or ALS, those are both 2 that we're looking at. But it could be for anything. So the idea is, well, what's the problem? People have tried for 40 years, 50 years to figure out treatments for Alzheimer's, and they haven't done very well, because when you start to test things on people, you really can't do very well controlled experiments, and you can't do many experiments anyhow. And then, of course, animals they're not the same as people. So to the extent that you have a in vitro system that mimics everything, and this seems to do that from everything we've studied. Again, we'll have a paper coming out in a couple of weeks in Proceedings of the National Academy of Sciences. But the thing is, then you could test thousands of things. And again, it's not going to be a proof until you do it in humans, but that's sort of the whole idea that you can do high throughput things, and that hopefully would enable us to say have a personalized ALS system, a personalized Alzheimer's system, or other brain diseases, you know, like Parkinson's. So that would be the hope. Actually, Mass General just started, you know, a new neuro institute, and they actually hired Alice as Stanton, who I mentioned, as their first professor there. So I'm hoping we'll someday be able to do things like that.
I imagine the advent of artificial intelligence will help with some of this research. Can you talk a little bit about how you see AI playing a role in biomedical research going forward?
Sure. Well, I mean, really, where it's most useful is when you have a lot of data. There's an awful lot of hype about artificial intelligence, in my opinion. You know, first of all, it's not new. It's been around for 80 years. But I think the advent of ChatGPT, you know, what a tremendous demonstration of what you can do with it. And I was showing John before a book that Reid Hoffman sent me. Reid started LinkedIn. And I wasn't paying much attention to it at first, you know, and then I looked at it, and you know, the front cover is the title of the book, but then I looked at the back cover, and there's this picture of me, and the quotes about Shakespeare about me, and Tesla about me, and stuff like that. I mean, you can do anything with it. But
Also, some photos of you in the
yeah,
in the book.
That's right, quite a few. It was interesting, so it's amazing technology. But coming back to this specific question, really where it's useful is when there's a lot of what I'll call very good data. So when I mentioned, for example, that brain on a chip, and we and some of our students and other people have made like hearts on a chip and GI tracts on a chip. Geo Traverso's done some of that at MIT and Harvard. Is that if you get a lot of data, that's really where AI is so useful. That's why AI, if you take ChatGPT, you can take a look at the dictionary, you can find that stuff that you had in Wikipedia or whatever just instantly and put it together. And so if you had thousands and thousands of pieces of data, then it's tremendously useful. In fact, when you talked about companies, Nick Gallicatos um, uh, and myself and Mike Sema, back even 26 years ago, we started this company called Transform Pharmaceuticals, which Johnson and Johnson ultimately acquired. And we had a really simple one simple idea. There are actually two we worked on, but I'll just pick one. And that is, if you take drugs, so maybe 50% of the drugs that have been discovered are not soluble or barely soluble in water, so they can't do anything. So what we did is there's things like what are called excipients. These are molecules, substances you could add to those drugs and see if it could make it more soluble. Now, before us, people might take one at a time. Well, we took thousands doing high throughput, and then we called it machine learning, but we used machine learning each time we tested thousands. We analyzed the structures and the combinations that work best and did another iteration. We analyzed what worked best then and did another, and we kept increasing it. And so that's a very good kind of almost simple example of where you could use it. But other people like Regina Barsley at MIT, as she's used it for getting better image analysis of breast cancer specimens. So there's all kinds of, and I think for diagnosis, you could certainly think about using it. So I think it's a very powerful technique, but a lot of this could have been done before. Now it could be better, faster, cheaper, so to speak.
Just going over everything you got going on, it's kind of mind-boggling to me, given that I can barely plan out my day. What has you most excited about the future of medicine right now?
Well, I always think about three things, when I think about the future of medicine. For me personally. First, it's making new discoveries. And the great thing about basic science and basic engineering, lots of things now have names. But I always think the things that could end up being biggest, and I think I made this quote once to the Globe in another interview, are something that doesn't have a name because it hasn't been discovered yet. I mean, a good example is CRISPR, and people heard from David before, but CRISPR, if you ask somebody 14 years ago what CRISPR was, they'd probably think it had to do with cooking. But, people, Jennifer Doudna, Emmanuel Carpentier, and Fang Zhang, and others, David, through basic research, they came up with ways to edit genes. And that's something like that's incredibly exciting. So a question might be, what's the next thing? Something we don't have any idea exists that people will discover. I think the second thing that excites me are turning these things into products. I mean, the mRNA vaccine, for COVID was a good example, but there are plenty of other examples too, which could lead to new treatments for diseases like cancer or rare diseases or anything. And then the third thing is the people. Really, I mean, one of the wonderful things for me being a professor is the students and postdocs I have, and they're professors or started companies all over the world, and so training the great people and seeing how they become stars, that's always very rewarding to me.
Yeah, maybe this is a question from the audience. How do you pick? You're often judging people's talent or their ideas. How do you select? Like, what do you look for like what stands out? How do you know what I mean? Like,
Yeah, I think so. Well, I mean, it may depend whether I'm talking about an industrial position or an academic position. Maybe just to do academic position, a lot of people hire somebody that has what I call very good qualifications. They've studied something a lot, maybe for 10 years, that's in the grant that you have. I mean, to me, what I've generally tried to do are pick people who are what I'd call are the best athlete. Even if they don't have a lot of experience, if they are out of the box thinkers, if they've had a track record of excellence, and they probably want to do not only good basic research, but they want to see it make a difference in the world, and you can see their passion. I mean, that's pretty much what we've done.
Well, I think everyone in the room here understands that the biotech sector it's been, you might call it an inflection point right now. There were a lot of stresses before the current administration went into office on the sector, more stresses following that. I'm curious, what do you think the biggest change you've seen in the sector in the last year, and also what does that mean here for Massachusetts?
Well, I think, I've had the advantage or disadvantage of being around a long time on this. So, I've seen this happen twice before. I mean, in 1992 and to 1994, and then obviously in 2008, and it happened to a lot of things. And both those other times, even though there were tremendous, people were very depressed about what happened, it came roaring back. I mean, and of course here, the time of roaring back after 2008 lasts a long time. And what happens is people get over excited, people, investments in things that are probably not that good and at valuations that are maybe way too high. So I think the last 3 or 4 years we're paying a price. I think we're obviously still in that. I still feel it'll come roaring back. I don't know when, but I still think at the end of the day, great science and great entrepreneurs. It's a combination of all kinds of people. I think I think that'll come back. And Massachusetts, I mean, again, I'm highly prejudiced, but even if you look at U.S. News and World Report, what are they pick the top three best schools. I mean, it's Harvard and you have Harvard and MIT, you know, what 2 blocks, 2 miles from each other, and so you have the best engineering school in the world, the best medical school in the world. You keep training great people. You have all these hospitals, and I think a tremendous infrastructure. So I'm still very, very optimistic. I mean, there'll be a number of things that won't do well, but it's hard for me to believe that, you know, I still think the sector will do great as it has for a long time. But it's peaks and valleys.
Well, we're actually coming up on our time, so I'm going to bring it back to chocolate here. You talk about Milton Hershey, the guy that eventually founded the company that we know and love, but it didn't work out for him. I'm not sure how many times he tried at first to build a candy business. It was more than two, maybe three or four or five. And eventually he hit upon a success. What lessons can we all take from that, particularly in biomedical research? And I wonder if you kind of take those lessons to heart yourself.
Yeah, well, of course, when I started doing a lot of these things in science, like I mentioned, failing 200 times. I mean, of course, I hadn't read the book about Milton Hershey, but what I have thought is great about maybe the culture in Massachusetts, the culture in the United States, and it goes back a long time, and is the never kind of give up attitude. Milton Hershey had a very different dream than I did. His dream was to start a candy store, and I think he failed about 8 times. But he wouldn't. He went bankrupt, but he wasn't going to give up on that. And I think that's kind of like what I call an entrepreneur. And I think that America has this great entrepreneurial spirit, I suppose, and I never thought of myself as an entrepreneur or anything like it, but I suppose being stubborn and really wanting to push hard to follow your dreams, and I think that's a great lesson, and that's also part of what still makes me optimistic, regardless of what else is going on.
Well, I'm going to close it there on a positive note. Let's give Dr. Langer a big round of applause.